Hey, Professor, some guy with a bulldozer just knocked down 2 old, beautiful, and healthy trees on the property behind my house. It's a housing development project by land developers. I don't want to trespass, but I need to know how big these trees are, and I'm wondering, how old are they?
Using Thales Theorem, a handy relationship formula that I'll show you, GPS software, and a graphics program like Photoshop, this will be easy to accomplish. You'll be able to accurately determine the height and width and will give you an idea of their ages. First, you can do a quick estimate using only your brain. Did you know that your arm is approximately 10 times your PID? That's the distance between your pupils. We can take advantage of that using something called parallax. You can use objects of known size to more accurately predict the actual size. But we can do a rough estimate right now just based on what we know. Let's look at the tree on the left. Since we're talking about a mature post-oak tree, let's assume it to be around 40 foot tall and 3 foot wide. Since these trees grow less than 2 inches per year, that means they're likely between 200 and 400 years old. As old as 400 because they likely stopped growing long ago. But without counting tree rings, we can't really know, and sometimes a tree like this can live to be over 1,000 years old. So, here's what you do. Stand exactly where you were when you took the photograph. Hold your arm straight out in front of you with your thumb in line of sight with the tree. Position your thumb on the edge of the tree. Now look with your left eye closed and line it up again with the edge. Close your right eye and open your left. Your thumb appeared to jump across the tree. Note how far it jumped. Halfway the distance from one edge to the other? 3 times the distance? Multiply that amount by our guess of 3 feet diameter. Then multiply that number by 10. That's the distance to the tree.
Well, Professor, my thumb moved about 3 3/4 tree diameters, so I get 112.5 feet.
Good. Now let's use Thales Theorem, also known as intercept theorem, to see how you did. We'll need 3 more figures for our geometric equation. Use a tape measure to measure the distance to your fence. Also, I see that there are about 5 pickets superimposed over the tree, so we'll use 1.58 feet for the width. Using the telemeter or acreage app on your iPhone, determine the distance to the tree again. Telemeter uses the same relationships along with angles, and acreage uses GPS.
The distance to my fence is 54 feet, and acreage shows the distance to the tree to be about 113 feet.
See, your monkey brain actually works pretty good. Just using your anatomy and parallax effect, you came within 3 inches of the GPS. Now let's plug those numbers into this formula. X over D1 is equal to W1 over D2, where X is the unknown width of the tree, D1 is the distance to the tree, W1 is the width of the fence, and D2 is the distance from your camera to the fence. We're looking at the relationship of the width of the tree is to the distance to the fence, what the width of the fence is to the distance to the fence. X over 113 feet is equal to 1.58 feet over 54 feet. 178.54 feet over 54 feet equals 3.3 feet. Yes, x equals 3.3 feet, or 39 inches. Now let's check this figure with a handy little geometric relationships formula. Using this formula, where D1 is distance from camera to fence, D2 is distance to tree, S1 is size of fence, P1 is number of pixels of fence width, and P2 is number of pixels of tree width. I converted our numbers to meters, then plugged in distances, and using that image in Photoshop, derived the pixel widths. Tree and fence are superimposed, so the same value, 96 pixels. Once again, we find the tree to be 39 inches in diameter. I did this calculation also for height and discovered that the tree is 39.972 feet tall. Remember that we guessed 3 feet wide and 40 feet tall? We were very close. Keep in mind that GPS has a variable margin of error. The global average user range error, known as URE, is around 2.3 feet 95% of the time. How will you use this information, monkey? There are generally restrictions on destroying trees, and one needs permits. In Austin, Texas, you can be fined $5,000 just for trimming your own tree if you're not a professional arborist. Given the location of these trees, I find it difficult that developers would actually need to bulldoze them since they can easily build around them. Who wouldn't want one of these in their backyard? I'm going to find out if they needed permits, and if not, see if I can persuade our city council to consider requiring them in the future. I'm not against progress, and these aren't banana trees, but we should be conservative with all of our resources. And it just makes good sense to protect our trees. Trees filter water, prevent soil erosion, and provide shade and a sound barrier. There's an additional benefit to property owners since trees increase property value. A little simple planning and those ancient trees would still be here.